All right, welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to discuss how you can be able to do this question of Pure Math 1 May June 2024 question number. It's around question number 10. All right. So we are told that the curve has equation y equals to 2 over 3x cubed minus 25x minus 56x plus 194 over 3, where x is greater than 0. The point which lies on C has the coordinates this. Show that the equation of the tangent to C at the point P is this. So first, we know that if you use differentiation, you can be able to get the gradient of a curve. So we're going to differentiate this part so that we can be able to get the gradient of the curve at the point C, at the point P. So we're going to say dy dx is going to be equals to, if you are differentiating, you take the power down, so it will be 2 over 3 times 3, and that's going to translate to 2x raised to power 2, because we are going to decrease the power by 1. And this one here, we are going to have minus 25. Then this one can be written as negative 56 x raised to power negative 1. So meaning if we take the power down, it becomes positive 56x. Then we subtract negative 1 from negative 1. Now this becomes what? 2. So this is going to be plus 56x raised to power negative 2. So once we have this, we are going to say, because we want to find the gradient at point P, so we're going to evaluate dy dx at the point x is equals to 2. So meaning that we are going to substitute anywhere we have x at this given point. So we shall have 2 into 2 raised to power 2 minus 25 plus 56 into 2 raised to power negative 2. And if we work out this, we are going to get our answer as negative 3. So the gradient of this curve at the point P, where we have 2 negative 8, is going to be this. Now, something that you need to remember is that when you are talking of a curve, now suppose we say we have this curve here, and we are trying to find the gradient, the equation of the tangent. If we are talking of a tangent, a tangent is a point that tangents a curve at one specific point. So meaning that if we have a tangent at this point here, P, which is 2 negative 8, it means the gradient of the tangent and the gradient of the curve at this particular point, they are equal. So we can also say gradient of the tangent is also equal, can say equals to negative 3, because the tangent and the curve will have the same gradient. But if it's the normal, it means that the gradient is going to be what? The gradient is going to be m1 times m2, giving you to negative 1. So we have to evaluate that. But for this case, our gradient is that. And the equation of a straight line is given by the equation y equals to mx plus c. That is the equation of a straight line. So it will mean that at this point, we say that this tangent passed through a point 2 negative 8. So the y coordinate you can see here is 8. The x coordinate here is 2. So this is y, this is x. So this is going to be negative 8 is equals to m is the gradient, which is negative 3. Negative 3 into 2 plus c. So in this given way, we can be able to evaluate the value of c. And that will mean that our c becomes what? Our c is equals to minus 8 plus 6, because minus 6, if you take it on this other side, it becomes a positive. This is going to be minus 2 as the value of what? The value of c. So the y-intercept of this tangent is equivalent to -2. Therefore, we shall say y is equals to -3x minus 2 as the equation of this tangent that we were supposed to find, and basically is what we have shown at this point. The point Q lies on C. Given that the tangent to C at Q is parallel to C at P. Find using algebra and showing all your steps the exact coordinate of Q. The exact coordinate of Q. Now, in order to work out that question, what we are going to do is that, because we know the gradient of the tangent at this point is -3, then we can identify another point Q, so which means that it will be having it will be having a tangent which is parallel to this one, so which will mean that the gradient of the curve at this point and the gradient of this curve at this point, they are the same. That's why these two lines are going to be parallel. So meaning, if we take this part that we have here, which is the gradient function, and we equate this part to -3, because the gradient we got here is -3, and also the gradient of this is going to be -3. So we shall equate this gradient function we have here with -3. So that we can be able to solve this equation, we check the value we shall get, and that will give us the value of x. So we shall say for part B, we shall take 2x squared minus 25 plus 56 x -2 is equal to -3. So this is the equation that we here that we have to solve. So this is going to be 2x squared plus 56x. I need to write this over x squared here, right? We just write it properly. So x squared, I've just taken this negative down, negative x -2 at the denominator, so it becomes positive. Then minus, this will be what? This is going to translate to 22 is equals to 0. So in order to solve this, I'm going to multiply all through by x squared in all the terms. So I'm going to have what? I'm going to have 2x power 4 minus 22x squared plus 56 is equals to 0. So this is the equation that we really need to solve. All right, so I can just do away with this part that I'm having here, so that we can be able to proceed with this question. So having this, we can say at this point, let m be equals to x squared, so that we shall have this equation reducing to 2m squared minus 22m plus 56 is equals to 0. I've let that so that I can be able to form a quadratic equation, which we are going to do what? We are going to solve. So this equation, if we solve it, let me just put this quadratic straight in the calculator. 4 or m is equals to 7. Now look at this. Since we had let this x squared to be that, then it means we are going to say x squared is going to be equals to 4, or x squared is equals to 7. Finding square root, we're going to have x equals to plus or minus 2. which is basically this part that we have here, this one. And x is going to be equals to square root of 7. And remember, we were told that x must be greater than 0. So meaning that x is equals to 2. This one has positive or minus, so x is going to be equals to positive root 7. So since x is greater than 0, we cannot take the negative, and also we cannot be able to take the negative at this point. So since our x coordinate for P was 2, then it means the x coordinate for Q is going to be root 7. And that is basically what you are supposed to find, the x coordinate. So the x coordinate for Q is basically the root of 7 that we have shown at this given point.